For the small data set, we're going to calculate the 90% confidence interval in the slope. Given our least squares regression equation is y hat equal to 1.5 plus 1.5x, and s squared, the estimate for the sample variation, is equal to 0.25. All right, so let's recall that for a confidence interval on the slope, we have our point estimate is b1 plus or minus a t critical value times the standard error of our estimate b1. So b1 is simply just going to be equal to 1.5. That's from our least squares regression line. A t critical value will come from a t distribution with n minus k plus 1 degrees of freedom. So in simple linear regression, this is n minus 2 because k is equal to 1. So n minus 2, and we have 4 observations, so n is equal to 4, so this implies that the degrees of freedom is equal to 2. So we can find the 90% critical value from a t table for the degrees of freedom of 2. So here is the degrees of freedom of 2. If we cruise across this row, this is the 90% confidence interval row because it has a two-tailed probability of 0.10. We could also validate that by scrolling down. We find 90% level here. So in that same column, we find our critical value of 2.920 for our confidence interval on the slope. 2.920 from the table. Now we need to calculate our standard error for B1. This is equal to S over the square root of the summation of xi minus x bar squared. So each one of the observations of x minus its mean. Well, we have our observations of x over here, so we can get started calculating that. We know what s is because we have s squared equal to 0.25. So s is equal to the square root of s squared, which we've been given is equal to 0.25. So s is equal to just simply 0.5. So that will be the numerator of our standard error. Now to calculate the denominator, we need to calculate the square root of the sum of xi minus the mean squared of all the observations of x. And so we know that x bar, we can simply just calculate it by adding these up and dividing by the total, is equal to 2. So if we take each observation, the first observation is 1, minus off the mean, square it, and then add on the second observation of 2 minus 2, square it, plus 2 minus 2, the third observation minus the mean and squared, plus the fourth observation, which is 3 minus 2, square this, take the whole square root. We will then be a little bit closer to finding this denominator. So here this is 1 minus 2, which is negative 1, squared, which is just 1. Plus 2 minus 2 squared, which is 0 squared, so this is just 0. Plus 2 minus 2 again is 0, squared is 0 again, and 3 minus 2 is 1, squared is just 1. So take the square root of this, and we get this is equal to the square root of 2, which is equal to 1.414. All right, so this is just the denominator of our standard error. So if we plug this in up here, 1.414, we get a standard error of our estimate equal to 0.3536. All right, so now we have all of the elements that we need to calculate our confidence interval. So again, this is B1 plus or minus our t critical value times the standard error of our statistic. And so B1 is equal to 1.5 plus or minus 2.920 times our standard error of 0.3536. We then get a margin of error value of 1.03, that's a little rounded, which means that our 90% CI for beta 1, our true parameter, is between 0.47 and 2.53, which means that on average we would expect our Y to change 1.5 units with a change in our x. Or we can think of it as with a 1 unit increase in x, y will be expected to increase by 1.5 units. If we interpret the confidence interval, it's the same idea where with a 1 unit increase in x, our y will change between 0.47 units to 2.53 units on average according to the 90% confidence interval.